for the morning session will be two students again from Diamond High School, and based on their past year experience in studying computing in high school, they will now share with you their vision of how they envision the high school computing curriculum to be. Yeah, so let's welcome Ambrose and Cheryl.
Okay, it's an honor to be here. Good morning, ladies and gentlemen. I'm Ambrose.
And I'm Cheryl.
We will be presenting on the projects of computer science education for pre-tertiary students. So, to start off, we are two students from Diamond High School taking computing as a subject. So if you want to contact us, you can contact us through this means or through Hackpad if you want. Here are the contents of what we are going to present today. So in Singapore, right, for our generation, if your parents are not in the IT industry, or if you're not joining the IT club, chances are you won't be exposed to programming in Singapore. So you are at the high school level, usually the stuff are overshadowed by other more general subjects like physics, chemistry, or biology, as compared to, say, computing within the syllabus. It's also worsened by the small number of high schools that are offering computing and the general lack of modules that are related to computer science in middle school or high schools. So, because computing is rarely taken, when we tell our friends that we are taking computing, so they don't know what we are actually doing in there. Most of the time, they just think that we are doing applications like PowerPoint or Photoshop, and then they don't really know what real programming is. So they just expect it's based on application proficiency. So the current curriculums around the world seem to be revolving around software literacy, and it's perhaps due to the rigor that is involved in computer science. So they learn as an end user rather than a developer. But with this kind of curriculum, you can't inculcate skills that are more related to computer science or thinking skills that are needed, or computational skills. So this poses a really big problem to the current world where everything is almost done by programming nowadays. So what in fact do we learn in our curriculum, the A-level curriculum, which is for the lecture exams? There are three main branches that we have, which is algorithms and design, interface and interactions, and systems engineering. So, for the current curriculum on algorithms and design, we will learn stuff like basic searching and sorting algorithms, namely bubble, insertion sort, and quicksort. So, we are also taught object-oriented programming more in both the Python style and in a style that is more befitting of the the more traditional programs like C++ and Java. Some of the more advanced data structures like the binary search tree or linked list are also covered. So regarding interface and interactions, we have stuff like UI or UX designs and relational database design also the concept of cloud computing. So this so that we can interact with the end user as a developer better. So the last one will be systems engineering. We cover some of the basics for project management or ways that we develop the system, so through the system development cycle or GANTT and PERT charts, as well as maybe managing a project so that we know how to manage a project by ourselves. So as we proceed towards the future curriculum, one of the first countries that have started to implement the curriculum is actually UK, where they implemented a new computing curriculum this year. What should we do in order to gain a better developer-oriented curriculum. So to start off, there seems to be a need for a more code-centric curriculum that allows students to be able to move up to learn programming at a higher level, instead of just looking around doing applications or something. Current syllabus also is targeted more towards exams, such as we have a 3-hour practical and a 3-hour theory session. So it's rather not, it doesn't really reflect the situation of the real world. So there needs also to be UX and UI skills so that they can learn how to interact with the user or make a proper interface. And the last part is definitely the real life applications, so that they know what is going on with the real world and not just, oh, we can make programs. So why do we want to teach in Python? It's actually a much better starting point for beginners as compared to the other languages like Java, C++. It should make through the simplicity of the subject, it should be more appealing to girls, which is one of the more pressing issues, because most of the computing science people are actually guys. Say if you go into a university, most of them are guys. So yeah, this is a XKCD slide just showing the simplicity of Python. And there's also an indentation that is necessary for Python to work. So this will also help to inculcate good programming habits. Say when you're going into another language like C# or maybe Ruby, everything else will be more presentable, so that other people can see what you're doing. So within our school, within our school lessons, right, there are 3 types of lessons that we will have: tutorial sessions, practical and theory sessions, and project practices. As shown above, this is one of the lab practices that we have been given at the past year, how to implement a quiz to find multiplication problems involving 1 to 10, one of the more simpler problems. So towards tutorial sessions, they're just sessions where we learn the knowledge of, say, project management or maybe a relational database. So our teacher will just go through the concepts and tell us what to do and how to do it. And after that, we'll be given practical and theory sessions to use our knowledge in a manner. And then the last one will be project practices, which will kind of model the real life situations. So in order to apply the concepts to our projects, right, what we have done is to use some methods like Google App Engine or Pygame, or through a hackathon like Code Extreme apps. So this helps us to apply concepts through the projects that we have done in the past 2 years. So frameworks related to Python are actually a good way to get people to make applications for use in the school. So so I'm going to show one of the applications that we have made in the past year, which is this is to report IT problems. So so if this is the administrator console, and then this will be this will be the error reporting area. So you just report any error, and then you just select the category and you report, and it'll show up on the admin console. Yeah. So if we use this kind of applications through frameworks, right, it will help to you help the students to make functionable applications instead of without frameworks. It's a great way for them to learn how to code as well. So we are also encouraged to do speed creation of code. So as mentioned before, there's the Code Extreme apps. There's a hackathon that we have to develop an app that pertains to the problem that we're given in the competition. And we are also encouraged to go for competitive programming like Google Code Jam. So we also have a mobile game development project to run up our year of studying Python last year. So this has allowed room for more creativity within students and piqued students' interest. And by aligning to students' interests, they are more motivated to learn and use code. We have used APIs, the PyGames API, in order to make our code. This is implemented through RenPy, so this is one of the game that we have made. So it's just, yeah. It's a visual novel that's targeted at girls, so something like this. Yeah. Within the game, right, we also have to come up with algorithms for the mini games, because it's a visual novel with mini games inside that is implemented by PyGame. So for stuff like this, we will use a program flowchart to show, say, what we want to do and how the logic flows. And then there's also a logic flow for the story, which is over here. I'm sorry. Okay. I'm sorry, it's not open, sorry. So Cheryl will talk to you more about the situation.
To round up, what we can apply from our current lessons are the projects linking academia to the real world. There are criticisms that academia is too theory-based and does not cover what the industry actually does. So, to tackle this, projects that focus on developing programs for the real world should be included in the curriculum. But not just any projects. To make them more meaningful, these projects should have an impact on the community. The theme could be based on a problem currently faced in society, and students can tailor their programs to help a certain target group. For instance, to tackle an aging society, students could come up with apps to help the seniors engage with their family members, or a game to help the young understand dialects and communicate with their elders. Or we can start with something closer, the school community, like in the Google App Engine project Ambrose has described. But besides this, how else can we improve? Let's start off with identifying the potential problems learners of code might face. Firstly, there's a lack of standardized material in the curriculum. For coding, there are barely any guidebooks aligned to the syllabus, unlike math and physics. There's an official guidebook by Cambridge and guides to programming, but this is somewhat different from the Singapore high school examinations. So beginners might not know what they're getting into unless they do their research. The second problem is immediately delving into code, especially for programming languages such as C++ and Java, which are relatively harder to learn. For beginners who did not prepare beforehand, this might be difficult to follow. However, as Ambrose mentioned, using Python to teach could be a good way for beginners to equip themselves with the essential knowledge to follow the class. However, the danger here is the different learning speeds, our third problem. For the experienced, it might be a steep learning curve where the student can go on to making programs and workable apps. But for the beginners, this fast start might tend to a plateau where the concepts are increasingly challenging and the motivation to learn might be diminished with fast takeoff of the experience. I can't do it. What can I say? I'm only a beginner. Those are some of the thoughts that plague the mind, and it becomes a vicious cycle where being a beginner becomes an excuse not to improve. This usually occurs in individual projects such as app creation. The really good students develop functional apps in a short period of time, while some of the beginners end up making a skeleton of an app. And when it comes to large group projects, beginners might end up doing the design role, which doesn't incorporate as much coding. For females, some of these problems may be applicable, but we have other challenges in this male-dominated field, namely asking, the lack of social support, and confidence. Let me illustrate with my personal experience. As a female, in the beginning, being in a male-dominated class, I was scared to talk to my classmates and ask them for help. What if they thought, "What a stupid question! Only stupid people cannot solve things like this." It was only during one of the assignments that I realized I wasn't alone. One of my classmates asked for help, and only then did I realize asking wasn't as bad as I thought. Generally, girls have some perception that asking makes them seem whiny and needy, especially when it comes to asking someone whom they're not familiar with. And it leads to an isolated learning environment where we begin to pile up with doubts until someone offers to help. This leads us to our second problem, the lack of social support. Females form the minority in most computer science classes, and in some cases, there might only be one girl in the class. While girls can forge friendship with boys, it isn't quite the same. Boys do offer to help and teach us the solution, but while solutions are important, girls place an importance on empathy. Let me explain. For girls, it would go something like, "Hey, do you solve that question?" "Yeah, but it was really hard." "I know, right? How do you solve it?" But with boys, it's a different question altogether. When I ask Ambrose a question, he'll give the occasional outburst of, "What? You don't know?" before teaching me, but though at times his explanations are a bit too advanced to understand. Not all boys are like that, but the rhetoric makes it seem like the person who's asking the question is the one at fault not knowing, and this can hurt one's self-esteem, which leads us to our third problem, the lack of confidence in the long run. So what should we do, you may ask? To tackle the lack of standardized material, students can consider compiling a textbook of what they've learned in the past year. A textbook by students for students. Let me show you an example. This is the textbook our seniors compiled and where we added comments to improve the content. This not only consolidates the content taught in class, but provides a guide to future students while accumulating the knowledge taught over the years. Perhaps the teachers and students out here could consider starting a class textbook in Google Documents. Next, to bridge the learning gap for beginners, a peer-to-peer tutoring system could be implemented. This could also be done in Google Documents, where the code could be shared among students. This is an example of one of our practices that Ambrose has commented on. Using the comments function, the more experienced students can mentor the beginners not by writing code for them, but only using words to point out possible areas of improvement. This way, not only would beginners benefit with the guidance, the experienced can also learn how to communicate effectively in code. To aid the understanding of beginners, another way to help them understand would be through Python Tutor. Python Tutor could be used to visualize the execution of code. This is an example of a recursive function to find the sum of a linked list. This helps beginners understand what's going on as each line of code is being executed. Next, to tackle the problem of asking, a class support group could be created on Edmodo, a learning site similar to Facebook. In this group, questions will be encouraged and anyone could post a query to the class or the teacher. In addition, teachers could post readings to supplement the materials taught in class. Next, to build up confidence, students could practice their coding skills on different platforms such as Programmer and SingPath outside of class by starting with simple questions and then moving on to tougher ones. This could be counted as extra credit if the students need a little motivation. We've covered how to improve the current syllabus and alternative methods of teaching. Now, let's move on to what people can do to improve the coding scene in society. Here are some problems leading to a lack of coders in many societies. First, we have a lack of schools offering computer science as a subject at the primary, middle school, and high school level. To pick up coding skills, one would have to turn to private institutions, which are expensive. A 4-day Java Essential course can cost up to 22,000 Taiwan dollars, and this makes it inaccessible to some. Secondly, while there might be computing lessons in schools, these only cover how to use software like Microsoft Word and PowerPoint, and do not cover any programming skills. Thirdly, while there are free online courses available, such as those on Udacity and Codecademy, not many people are exposed to such options or do not have the time to commit themselves. What we can do is to push for computer science to be integrated into the curriculum, possibly as an addition to the lessons teaching software skills. To interest the young, initiatives such as electives and camps, which we'd like to call Learnathons, as well as mini tournaments could be implemented. This is to expose our young to the wonderful world of computing. To integrate computer science into the curriculum, we could consider the use of Hour of Code to teach concepts. In an hour of code, Scratch is used to introduce programming concepts, and students will use blocks of code to solve the problems. Starting off with blocks of code might be useful to help students grasp the general idea of what's going on in a program. And for practices, primary schools could consider the use of SingPath's drag and drop track, where they will drag code to solve problems. For middle school, they could consider the use of the coding track in SingPath, where they will write the code themselves. For the curriculum, such online resources could be considered. the use of computer science circles and how to think like a computer scientist for teaching in Python, and Go develop IT materials for a more diverse range of topics, including HTML, CSS, and JavaScript. To pique the interest of students, electives could be considered and held in school as enrichment programs, possibly during curriculum time if there is an elective day or after-school enrichment. Students can explore a variety of courses catering to their interests, ranging from game development to making websites. Some of these courses could be supervised by a computer science teacher to save on resources, or could be conducted by external vendors if there are funds to do so. For the Learnathons, we visualize them in the form of holiday camps held in the school computer science lab with a supervising teacher. In these camps, students will learn computer science concepts and basic coding through free online courses such as those on Udacity, Codecademy, and Coursera, so as to address the issue of cost and accessibility. Students will be given headphones so as to watch the tutorial videos and learn at their own pace. If they have any questions, they can approach the teacher, and at the end of the lesson, they could have a mini tournament where they solve 10 questions on what they have learned. The teacher could use SingPath to create a tournament with questions from different topics. A small token or a gift could be offered to spur students to aim for top coder. We hope that through initiatives like this, more students could pick up coding in the future. Thank you for your time, and we look forward to the development of more societies geared towards coding. Please feel free to access our sites through the, through the QR code on the screen. Sorry, and thank you for your time.
Thank you.
Okay, thank you very much. Any questions from the audience?
Sorry, I just want to commend the students. I think they did a fantastic job. Just a quick question, right? As you said, there are not many students who choose to do computing in school. And what were your decisions? Why did you choose to do computing?
Okay, so for mine, I actually had an interest since like primary school on how stuff works. Like I had first glimpse of say games in 9 years old. So after playing it for a while, I realized that there should be something behind it that's making it work. So I had a growing interest since then. So in the secondary level, I joined the Infocom club to further pursue this interest, and then now I'm in computing.
For me, I didn't have any background of computing in middle school, but in high school I decided that because the normal science subjects, physics, biology, chemistry, for me those science subjects didn't have any immediate applications currently. Like I can't exactly use physics to maybe make something because I don't have enough knowledge. But for computing, once you have that at least a basic knowledge, you can solve problems and you can make programs to help yourself, and you can make games. So there's this idea of something, you can create something tangible with computing that will impact you directly. So for me, it was more, computing was something that had a practical application immediately, and it didn't matter if I was going to take computing in the future because computing could be applied anywhere in my current life. So instead of going mainstream, I chose to do computing for my high school curriculum.
Okay. Is there a reason why you think there are not more people thinking that way?
Because for computing, it isn't introduced in the middle school curriculum currently. So the students might not be exposed to what computing really is. Then, because they don't have the knowledge, they would prefer to go with something more familiar in their high school, because the high school examinations would determine where you would go for university. So they might prefer to stick with something more familiar, such as the science subjects taught in middle school, instead of something that's foreign like computing.
Yeah, so the classes are the computer classes are elective, and is that?
Oh, we take it as part of our main curriculum because we have a choice of 4 subjects that we can choose, and on these in these 4 subjects, math is compulsory. The rest you can choose your own.
And what's the percentage of female students in the computer classrooms?
The class has 24 students, and we only have 3 girls out of.
Oh, okay.
Yeah.
Yeah, I was wondering that. And another question, in learning computing, if you're, say, a starter, and if you think students are learning directly from like sites like Audacity or Code Academy, how easy do you think is to learn it without the classroom setting and without the peers?
Definitely, the commitment to learn won't be really there. So if you've seen before, this kind of MOOC, massive open online courses, right? All this stuff usually have a low pass rate, like because they don't have really most people will just look over there and not finish the courses. So definitely, if you have a classroom setting and you have someone to mentor you and guide you along, right, you'll be more motivated to do stuff and work. Yeah.
But for beginners, for the high school level, I think Udacity would be a suitable introduction to programming. But maybe for middle school students, the teaching of coding itself might be a bit difficult to learn. So perhaps they could start off with blocks of code using Scratch, or perhaps they could do something more introductory rather than going straight into code. Because for me, I think the grounding of concepts are very important for the first few years. So perhaps they could be introduced to the concepts before going into writing code themselves.
Okay, thank you. I feel like if I were like students right now are really like lucky in a way that you guys have resources I never had as a student. Thank you.
Thank you.
Okay, thank you very much for your questions. And please feel free to interact with the students during lunch. They are actually quite recognizable in their school uniform. Yeah. So if not, I guess I'm the only one standing between you and lunch. So lunch is at 12:10. Oh, sorry. Yeah, it should be 12:10 at 4FC, R4, and 3F. And if you are vegetarian or pork-less consumer, then it will be at R4. Yeah. So please enjoy your lunch.